Okay, it is time. Let's get started. Today we're going to delve into the world of fertilizers and fertility management. And this is the best stuff of the whole class, I think. Um, a few things to consider, and I think we maybe even dabbled into this a little bit yesterday in lab. But in some ecosystems, we've got plants that grow and they do just fine. We don't add fertilizer to them really, and they just kind of recycle nutrients within their own kind of sphere. And that's great. Where we grow crops, it's a completely different story. And the biggest reason for that is that when we grow a crop, usually what we try to do is get as much crop off of that field as we can and then send it to somewhere else, right? We send it to feedlots for the cows to eat. We send it to food processors that send it to people to eat. And when we do that, we grow these fantastic crops, but we also remove all the nutrients that go with them. And so that would be more of an example of a managed system where we need to add inputs in order to maintain production. So things within a system can vary. And this is something that we've already kind of talked about a little bit. And what we try to do with our fertilizers is provide enough nutrient so that we can maximize our yield, but not go to the point where we're adding too much, losing money, and not getting any yield benefit out of it. And so if you take and look at maybe three examples, field A, B, and C, you can see that with field A, as you add more nutrient, it's doing nothing, okay? And so we can kind of assume that this field is not deficient in anything. Field B, we get a really nice response to added nutrient. And we can say that to begin with, this field was probably deficient in whatever nutrient we're talking about. Now, in this example, we've got this field C where we add a bunch of nutrient and still nothing happens. Well, what that means is there's probably some other factor that's going on that's causing it to not produce very well. It could be water, it could be, disease, weeds, something like that that's causing some kind of pressure where our added fertilizer isn't making any difference. It could be salts. And with the whole thing, we have to weigh costs with benefit. If we want to maximize our yield, we need to add this much nutrient. But the cost of doing so might be such that the area between here and here, our cost and our return, is kind of small. And if we kind of move down this curve right here, this gap widens. And so the profit for adding this much nutrient for that much cost is kind of maximized. Fortunately for me, I don't really go into the economics of it for like a specific grower. And that's something that they kind of have to hash out on their own. And it's a lot, it's kind of a difficult question. Okay, so in order to do this, one of the tools that we have at our disposal is soil and tissue testing, okay? We do this to determine any variability that might exist in the plants and to monitor their status. We can do this as a baseline, and we can do it for both tissue and soil. What I typically do and recommend is that folks sample their soil at least once a year, and sometimes they do it multiple times a year. With tissue, so we're taking a part of the plant, like a leaf or a petiole or something like that, and we're monitoring the nutritional status of that tissue throughout the growing season. And in that case, we might do it every week. I even know some guys that do it twice a week. And that way you can kind of track trends and you can say, all right, I added 20 pounds of N and I watched my petiole nitrate do this, or I didn't add any and it kind of flattened out. And so you can kind of watch those trends through the course of the year. Now with the soil, really its intention is to predict nutrient availability for one growing season. But there's a lot of factors that could go into play with that. We'll get into some of that in a little bit. With the tissue, it's at a point in time. And so we can't like take a tissue on a Monday and expect that by Friday it's going to be exactly the same. It's not. And so we're just looking at a specific snapshot in time with the tissue. Okay, some things that a soil test can't tell you. It can't tell you when to add fertilizer, what type of fertilizer to use, nor how to apply it. This is really, why does it say how much fertilizer to add? Because we've talked about fertilizer recommendations quite a bit in this class. And I think we've got some really good tools for determining how much fertilizer to add. There are certain factors that go into play here, though. Let me give you an example. So if you bring your soil in and I have it tested and it says you need to put 100 pounds of nitrogen on your wheat crop. Well, that's all fine and dandy, but maybe you as the grower or you as the field man knows that if you add 100 pounds, it's not going to be enough. Or maybe you know that you've got water issues in your soil and that adding 100 pounds is going to be too much. So I think maybe the reason I put this disclaimer up here is that there is some personal interpretation that has to go into the data, and just kind of some massaging of the numbers so that you usually know what's best versus just a flat recommendation that you get from a lab. Now let's talk about sampling. I was actually out sampling this morning. Sampling makes me tired, excuse me. And it was cold too. Gosh dang it, there was frost on the seat of my four-wheeler. But anyway, there's a bunch of different ways to do sampling, and I'll tell you about each one of them. The one that's probably most common is random. That's what I was doing this morning, where you go out into a field and you pull random points and you composite those together and take a sample. A grid is where you'll go in and using typically kind of a computer program, you'll mark off like a 1 acre grid and you'll take a sample at each grid point. So in a 100-acre field, you might have 100 samples. An area or a zone configuration is another popular one. So let me show you about each one of these. So random, this is where you'll go into this is dumb. Why does it say that? If you're going to do it randomly, why in the world would you use predetermined points? Ah, that's much better. Okay, so what you'll do in a random sampling is you'll go into a field. This is a crappy aerial image of a not round field, but you go in here and you'll take using a soil probe usually, you'll take a poke at each different point. You'll add those into a bucket, mix them up really well, and then you'll send that sample in to be tested. A general rule of thumb that I use is that regardless of how big your field is, you'll start with 10 points and then add 1 point for every 5 acres. So if we want to do the math, let's use a 100-acre field because most of the, a lot of the pivots are running around are about 100 to 120 acres. So if I had a 100-acre field, I'd start with 10 points and then 1 point for every 5 out of 100 acres. So that's 100 divided by 5 is 20. So I'm usually in a big circle. I'm taking 30 points and mixing those together. And the reason we do that is we try to get good representation across the entire area of the field. Does that make sense? Have any of you guys pulled soil samples before? It's pretty fun work. It's okay. I don't mind it. Great. Now you know, right? If someday you get hired on to take soil samples, if I ever catch any of you like driving next to the road on the field and like digging up 1 or 2 points and putting it into your bucket, we're going to have a problem because that's a crappy way to do it. We've got to get really good representation. The reason that's so important is when you take this stuff into the lab, you know, you get these recommendations, and a lot of times growers are making fertilizer decisions based on this sampling, and it could, you know, it could cost tens of thousands of dollars per field, and so we need to do a really good job of sampling. All right, that's random. Now in a grid, what we're doing is these are lined up in a perfect line. And what we've done is we've gone in here and these points are GPSed, and we'll drive to each point and we'll take a bunch of little pokes around this point, put it into a bag, and that's one sample. So in this field, I don't know how many points there are, but I'll do this quite a bit in the fall, especially with like the higher value crops, potatoes, carrots, ground that's going into orchards. They'll go out and grid it, and then you can kind of the benefit of gridding is that, let's say that you go out and you test potassium right here and it's, I don't know, maybe 115 parts per million, and then you come in here and it's 250. Well, knowing the difference between that and that, we can create a spread map and we can variable rate the nutrient applications so that we don't, you know, spread 150 on the whole field, because there might be just 2 or 3 points in here that are really high. And so we'll come in, put a high rate down, high rate, and then we'll make a lower rate pass right here and maybe here, and go back and, you know, you get how variable rate application works. And usually that works because we're doing a grid type of analysis. Lastly, we'll do it in zones. So in the zones, we'll say, all right, this is maybe a high spot. This is a low spot that produces a little bit better. And then we've got these others in between. And so we'll go in and we'll take, you know, 10 or 15 points out of here, call it zone A. We'll take 5 points out of here and call it zone B, zone C, and zone D. And that way you can kind of manage these as separate blocks if you get a lot of variability in the soil. So that's a zone mapping and zone sampling. Any questions on sampling? Okay. Now, where and when do we sample? So the rule of thumb is that we need to sample in the root zone. Now, for most crops around here, I'll do a 1 foot sample, okay? And keeping in mind that there are crops that do root deeper than 1 foot. But having said that, most of the fertilizer recommendations are written for a 1 foot sample. So keep that in mind. If you ever do like a 6-inch sample, for one thing, you need to indicate it on the sample. And for another thing, you need to remember that most of the recommendations are based on a 1 foot sample. And if we take a 6-inch sample, what we're doing is, you know, as you move down the profile, the fertility goes from basically high to low. And if we only took a 6-inch sample, we're getting basically the highest amount of fertility in our sample. And so it might say that we don't need to apply any phosphorus. But if you're on the border, and if we would have taken that 1 foot sample, you probably do, because there's less fertility down here that would have kind of dilute that composite sample out. Uh, Watch out for pipes in the ground. I don't think I've ever hit a pipe, but like if you go into an orchard or something, you might be aware of where the irrigation lines are so you don't probe down and poke a hole in somebody's pipe. Okay, tissue sampling. Now, this is something that's a little bit finicky. For me, when I go out and tissue sample, especially on the stuff that I do every week, I will go out and I'll sample in the same place in the field. I'll do it at the same time of day. And I try to be really consistent in that sampling. So be aware that tissue sampling can be finicky, and we need to, be as consistent as we can. If there are areas in a field that look weak, like, maybe we're having some kind of fertility issue, I'll go and sample that area separately and then send in a good looking sample as well so I can kind of make that comparison. This last thing right here, the location on the plant, that's really important, okay? And let me tell you why. Let me pull up a whiteboard here. And draw a plant. Okay, so let's say this is a corn plant. Draw a little ear of corn right here. It's got some tassels sticking out of it. Or some silks, I'm sorry, the tassels live up here. All right, now if you were to go out and you had some corn plants that were acting up, where do you take a sample at? Now you guys know that nutrients and their mobility is variable, right? So if we've got things that are mobile, if we've got like an NPK or a magnesium deficiency, those are likely going to show up in the older tissue. And everything else is going to show up in this newer tissue, okay? So if we say, all right, something's showing up funny, which leaf do I take a sample from? Well, we've actually got, you guys look at the camera here. This is the Plant Analysis Handbook. This is the Bible for determining where on a plant we need to take a sample from. Okay, so let me just tell you right now that it's highly dependent on the crop. If we're talking about corn, usually what they suggest is you take the leaf that is opposite of the ear, if there is a ear. And if there's not an ear, you take the fourth fully developed one. So 1, 2, 3, this one right here. So it depends on the time of season. It depends on the crop. And if you ever have any questions about it, you guys have my cell phone number and you can call me anytime and I'll let you know, because it's super important that we get the right leaf. If you go out and sample this leaf right here, for example, you're not going to, we can't interpret what that means, okay? We've got to have the right leaf to make the right interpretation. And if you've got the wrong one, it's not going to make any sense. All right. Now, one other thing that I want to point out is you guys have seen a potato leaf, right? Kind of looks like this. It's got these little leaflets on it. Okay. Now, just a little bit of anatomy lesson right here. This whole thing right here is called a leaf. Okay, these little guys right here are called leaflets. Leaflet. And then this structure right here that's holding everything kind of together, it's kind of a stemmy structure. This is what we call a petiole. Now, petioles only exist on dicots. Okay, you guys know the difference between a dicot and a monocot plant? Okay, potatoes, a dicot, grasses, corn, those are monocots. So if you come to me and tell me that you have a corn petiole, I will laugh in your face because that is like looking for gonads on a sow. I didn't see enough laughing. That's a joke, guys. It's funny. Sows don't have nuts. Okay. And corn plants don't have petioles. Okay. This is only for the dicots. Okay. Great. I think I'm getting sidetracked here. Let me go back to our, here we go. We've talked about calibration enough. I think I'm going to skip over this. All right. Now this matrix right here is kind of some potential, these are some potential things that can happen when we do a soil and a tissue test. So let's say, for example, on this upper left one right here, that we go out and we take a soil test and the numbers are coming back high. And then we go out there and we take a tissue test and the numbers are coming back low. That's interesting. In this instance, let's say that the soil test comes back high and the tissue comes back high, then that tells us something else, okay? Again, if we have a low soil test and a low tissue test, that tells us something. And in this case, we've got a low soil test and a high tissue test. So these are some potential outcomes of our testing. Now, these tell us a few things, right? Let's say that we've got a lot of stuff in the soil and very little in the tissue. Well, we've probably got a root or water problem going on. Okay, usually if we've got a lot in the soil, we tend to have a lot in the tissue, unless the plant can't take it up. And that could be because of a root or water problem. Okay, in this case, we've got a high soil test and a high tissue test. Well, we're probably where we want to be. Okay, and so we probably need to hold back on adding any nutrient. In this case, where it's both are low, we don't have enough nutrient and we need to add some more. And this last example is if we have low amount in the soil and for some reason our tissue is really high, this is probably an instance where we maybe have some contamination. But to be honest with you, I don't see this one too terribly often. Okay, let's get into fertilizers. So depending on, there's a million different fertilizers out there, guys. Okay, and let's learn a little bit about percentages and what the nutrients mean on like a certain bag. Okay, so have you guys ever gone to like the home and garden store or wherever and you've seen a bag and it says 16-16-16 on it? That's a pretty common type of fertilizer that homeowners use, and we call that 1616. Okay, and what that means is those numbers mean something. It's an indication of how much N, P2O5, and K2O are in that bag. Okay, so for simplicity's sake, let me go back here for a second. Let's say that we have a 100-pound bag of 1616. Okay. If 16% of that is nitrogen, how many pounds of nitrogen do we have in that 100-pound bag? Wade, what do you think?
16.
Yes. Okay. Yeah, I made the math super easy, right? Okay. So we've got 16 pounds of nitrogen. We've got 16 pounds of P2O5, and we've got 16 pounds of K2O in a 100-pound bag. So what's the rest of it, you ask? It's usually just filler, okay? So keep in mind, when you buy fertilizer, and if you're buying triple 16, you're really only getting, what's 16 plus 16 plus 16? You're only getting 48 pounds of actual fertilizer out of a 100-pound bag. The rest of it's filler. Okay, Rod, ask me what P2O5 and K2O, what the heck does that mean? Okay, the answer to that is those are kind of old, archaic ways of expressing phosphorus and potassium. And we just cannot let go of this, you guys. We can't get away from it. Now, all right, let's say that someday you're a farmer or you're a fieldman and you're growing crops and you get a lab test back. Your lab test is going to say that you need to apply 50 pounds of P2O5, okay? That's not 50 pounds of P, it's P2O5. But, because everyone's lazy nowadays and always, we just say P and K. Okay, so there's kind of an unspoken understanding that if a guy says that he needs to put on 50 pounds of P, what he really means to say is he needs to put on 50 pounds of P2O5. And if you guys can remember back to yesterday with our phosphorus lab that we did, you'll notice that those recommendations are given in pounds of P2O5 and not P. So that's what those mean. They're just old ways of expressing P and K. But I think we usually make it pretty easy because, like I said, lab recommendations are given in pounds of P2O5 and K2O. But keep in mind that people are just going to say P and K. But what they actually mean is P2O5 and K2O. All right. So let us do the following. Let's do some example calculations, and we can kind of work these together, okay? I posted an assignment on Canvas for you to do. You have until 5 p.m. on Friday to get that done. We're not going to meet tomorrow, and I would suggest taking class time to work on these calculations. And most of them are really pretty easy. It's just using ratios, percentages to make these calculations. So let's say that we get a recommendation to apply 50 pounds per acre of nitrogen to a 10-acre field. All right. So the first thing that we need to do is we need to calculate the amount of nitrogen that we need. So 50 pounds per acre times 10 acres. That math is so easy a caveman can do it, right? We need 500 total pounds of nitrogen. Now, let's say that we're using a fertilizer. A common one is urea, and it's only got 45% nitrogen in it, okay? So we know we need 500 pounds. Our product only has 45% of nitrogen. So what we do is we take that 500 that we need, divide it by the percentage of nitrogen in the product, and we determine that we need 1,111 pounds of urea to get our 50 pound per acre application. Simple enough, right? That makes sense. Remember, when you're doing this math, you're generally, when we're talking, okay, you need to use a product like urea that's 45% N, your application is going to be higher than your recommendation. Okay, we have to put on basically twice as much urea because it's half as, if it was 100% N, then we just put on 500 pounds. Okay, now let's switch things up a little bit. Okay, we still need to put on our 500 pounds, But now the fertilizer product that we're using is monoammonium phosphate, which is MAP 1152. So, okay, 500 pounds. And in this case, we've only got 11% nitrogen. So we actually have to put on 4,545 pounds of 1152. But we're getting some P out of that too, right? And when I say P, I mean P2O5. This is 52% P2O5. So the question is, how much P2O5 do we get out of this? And the answer is, we put on this to meet our nitrogen recommendation. And if it's 52% P2O5, then we put on 2,364 pounds of 1152. Excuse me. We put on 2,364 pounds of P2O5, but we did that over 10 acres. So really, we've put on 236 pounds of P. Okay. This is not extra credit. This is an old slide. Here are some common percentages for different fertilizer products. So ammonium nitrate is 35% N. Monoammonium phosphate, we just said is 1152. Why is this wrong? It says 12 and 27. Do you have any idea, Madison?
No.
Okay, the reason this is wrong is because this is showing it as percent P and not percent P2O5. So really, I want you to kind of ignore this table. Okay, because in fertilizers, we deal with P2O5 and K2O. But the N is useful, right? There's no conversion there. Anyone ever worked with ammonium nitrate? This is the stuff that the guy back in the 90s used to blow up the building in Oklahoma City. If you mix ammonium nitrate and diesel fuel, you'll create a bomb and ignite it. So it's actually kind of hard to get a hold of ammonium nitrate anymore. All right, here's our urea. It's saying 47%. Usually it's between 45 and 47. And here's some other ones. Aqua ammonia, we don't use that very much anymore. We talked about anhydrous the other day. It's 82% nitrogen, so that stuff's pretty hot. Okay, that should give you the tools that you need to answer all of those fertilizer calculation questions. And I would suggest showing your work on that assignment, because if you just get the wrong answer, I can't even give you partial credit for it, you know. So show your work, and if you guys want to work together on it too, I don't care. That's fine with me. Okay, I think we're getting just about to the last of stuff here. There's such thing as soil applied and foliar applied. Usually when we're doing a soil application, it's a large quantity, and we can, because of that large application, we can induce some potential plant damage. But usually that's not the case unless we're working with something that's really salt sensitive. This works great, especially when we don't have a crop growing, okay? Because we can kind of disperse that nutrient, you know, across the entire plant. Usually with the foliar application, this is something we're applying in smaller quantities. We can still damage the plant because when we're applying it directly to the tissue, that contact with the nutrient can cause burning. But there are a few limitations, you know, if we're adding either of these to soils that, you know, we talked about pH interactions, that's something that can be a limitation. And I don't know what a system mobility constraint is. That's wacky. This is easier. We can apply nutrients through circles, through airplanes, things like that. Gosh, granular versus liquid. I think that you guys know what that is, right? This is like a solid. Fertilizer comes in little white pellets or blue or red. I've actually got some laying around here somewhere. Yeah, they're too far away. I don't want to go get them. A broadcast application. This is like easy stuff, right? This is where we spread the fertilizer evenly across the surface of the soil. If we band it, this is generally where we apply it in a small area. A lot of the times when we're planting, we'll have fertilizer tanks on the rig that we're planting with, and there will be a little band that we hope that the roots are going to grow through. We talked about variable rate application. The opposite of that is a uniform rate. We can apply via sprayer or irrigation. We can also broadcast foliarly. Okay, that would be like an airplane, or if we're running it through the irrigation. And you can also variable rate these foliar applications. That's a little bit more tricky, but it can be done. Okay, that is all I've got for today. Do you guys have any questions for me? Okay, well, if not, good luck on your fertilizer calculations. That's really fun. I do that stuff every day, and I think everyone should know how to do it. If you get stuck, let me know. And if you want to, I end up getting quite a few messages through like Canvas, but I check Canvas like once a day. And so if you want to text me, that probably would work if you need help sooner. Okay. All right. We will be back on Zoom on Monday for our final lecture. I'll see you then.